Hello everyone, welcome to the channel Cyclotron. In today's video we are going to discuss about some last minute tips for your physics examination, and I have received quite a lot of requests from many students that they are facing problem in completing and coping up with the syllabus of physics in such short time. So first of all, I would request all of you guys to keep calm and be relaxed as much as possible. Do not panic and do not think physics to be something rocket science. It's a very easy subject, and do not stress yourself at any point. Do not think that you won't be able to cope up with everything and you will get bad grades. Be positive and try to complete as much as syllabus as much as you can, and those who have already completed the syllabus quite ago, it's very good for them, but still look into this video. I think this video is going to be helpful to you guys. Okay, so let's start. First of all, I will start off with the chapter magnetic effect of current. This is on special request. Some of you were telling me that this chapter is quite weak in your side, so I'll help you guys with this chapter, and then I'll try to complete all the important chapters. There are very few chapters in your syllabus which are important, because I know the syllabus is huge, but you know the fact that 70% of the marks comes from 30 to 40% of your syllabus. So do not think the syllabus to be very huge. It's actually a very small and short syllabus. You have to utilize your time very wisely, and you have to study very intelligently. If you are wasting your time in reading stuffs which are not important, then you are going wrong. And one more thing I want to add on, that keep your cell phones away from you as much as possible. Do not allow any distractions in these 2 days of your life, because after all, these are the most important days of your life, and the result which is going to come up at the end of the examination is very important for your life. So keeping that in mind, be sensible and try to adjust with the situation that you cannot allow any kind of distractions and social media like WhatsApp and Facebook in your life, and just focus to your studies, and I hope after that you will get a lot of time to enjoy. Okay, so starting off with the chapter magnetic effect of current, first of all we have the topic Oersted's experiment. So this topic is not very important, but to understand magnetism properly, it is important to know Oersted's experiment. But for your board's perspective, I would recommend you not to waste your time reading this part, because I know it's given in the NCERT and CBSE strictly follows NCERT, but still I would recommend not to read this topic Oersted's experiment. It is not required. Next, coming up to the Maxwell's corkscrew rule. Okay, I think many of you have problem understanding this rule, that which direction is meant for what. So I will upload a video in my Twitter or Facebook, or maybe both, and if possible in Instagram as well, an alternative way of remembering the Maxwell corkscrew rule, and to figure out how to find out the direction of current and the direction of magnetic field and the direction of force. Okay. So talking about some basic ideas, that what is the SI unit of magnetic field. Many of the students make mistake in writing the magnetic field's unit wrong. But let me tell you, the unit of magnetic field, SI unit of magnetic field is Tesla, T, we denote it by T, and we spell it TESLA, Tesla. Again, moving on with some basic ideas which are very important for tomorrow's examination or day after tomorrow's examination. As we know, if charge is there is a presence of electric field at that place. and the presence of electric field is independent of motion of the charge. But when the charged particle Q is at rest, there is only presence of electric field. But when the particle is in motion, there is electric field and also magnetic field. We use a vector for both of them because both of them are vector quantities. Electric field and magnetic field, both of them are vector quantities. Now talking about magnetic field, the experimental value of the magnetic field was found to be mu naught by 4 pi into q, the v vector into r vector divided by r cube. So what does q mean? Q is equal to charge, v is velocity of the charged particle, and r is the position vector of the point from where the magnetic field is measured. Now talking about some basic formulas which will be important for you for the following exam are, first of all, Biot-Savart's law. So what does this law describes? Let us assume that there is a wire which is carrying a current I, and we also assume a small current element dl. So what is dl? dl is a small unit of the whole length of the wire. Then let us consider a point P. So the position vector of the point P from the current element dl is r, and the angle between the position vector and the current element dl is considered to be theta. So there is a small derivation which is very important for your board examination, which leads to the formula. Let me write down the formula first, which is first of all most important to remember. So the formula is dB is equal to mu naught by 4 pi into I dl cross r divided by r cube. Here I is the amount of current flowing through the wire and dl is the current element, r is the position vector of the point P from the current element. This formula also has another form. dB is equal to mu naught by 4 pi I dl sine theta by r cube. So from where this dl sine theta come? As we all know, we have studied it in our class 11 that cross product gives us a sine theta, and this r cancels off one r and it gives you a square, and which leads to r square. So moving on to the derivation, which is very important for the examination tomorrow or maybe day after tomorrow. whoever is watching it at what time. So according to Biot-Savart's law, the magnitude of the magnetic field or the magnetic flux density at point P due to current element dl depends upon the following factors. Number 1, magnetic field is directly proportional to I, that is amount of current carrying in the conductor. Number 2 is B is directly proportional to the current element dl. Number 3 is magnetic field is directly proportional to sine theta. This actually means that the magnetic field is dependent on the angle between the position vector and the current element on the wire. So if we combine all these factors, keeping a constant, we get the formula that dB is directly proportional to I dl sine theta divided by r square. If we bring a constant k, then this equals to I dl sine theta by r square, and this k is nothing but mu naught by 4 pi, which has a value of 10 to the power minus 7. The Biot-Savart's law can also be written as B is equal to mu naught by 4 pi I dl sine theta by r square. Okay, let me first tell you some of the very important formulas which are important for the examination, and you have to remember those formulas. Number 1 is Lorentz force. Which gives that force is equal to Q into E plus V vector cross B vector. When a charged particle moves in a combined magnetic and electric field, then the force acting on it is known as Lorentz force. So when a charged particle moves amongst a magnetic field as well as an electric field, the force applied or the force experienced by it is equal to Q into E plus V cross B. Here V is the velocity of the particle and E is the electric field of the particle. So we can break down this formula and write it in a bit of detail so that you can understand it better. So the force experienced due to the electric field plus the force experienced due to the magnetic field gives you the Lorentz force. So as we know, force experienced by an external electric field is QE and force experienced by an external magnetic field is QVB. So I would also request you to once go through the properties of magnetic force on charge. So this is the list of properties of magnetic force on charge, but you guys take a screenshot or let's see if I can put this on my Instagram page or Facebook or Twitter page. It will be quite helpful for you guys. So moving on. So just read this, guys. I think you can understand this is not to be explained that much, because if I go into explaining all these points, it will take a lot of time. Just read this, take a screenshot, or I'll definitely put it in my social media pages, so just check it out. One thing which I forgot to add on, that the CGS unit of magnetic field is Gauss, and the relation between Tesla and Gauss is 1 Tesla is equal to 10 to the power 4 Gauss. Another topic which is quite important in this chapter is motion of charged particles in magnetic field. So here let us consider a magnetic field of B vector and the velocity of the particle to be V vector and the angle between them to be theta. So according to the Lorentz force formula, force is equal to QVB sine theta. If we consider case 1, the angle between velocity and magnetic field to be 0 degree or 180 degree. That means if it is 0 degree, it is in this direction, and if it is 180 degree, it is in this direction. Parallel and opposite. So the net force comes out to be QVB sine 0 degree or sine 180 degree, both results to 0. So the net force is 0. So the path followed by the particle is always a straight line. Then moving to case 2, this is quite important, and the derivation which I am going to do is also quite important. In case 2, we will consider the angle theta to be equal to 90 degree. That means the magnetic field is in this direction and the velocity is perpendicular to the magnetic field. If we consider the magnetic field to be into the page, so talking about direction of magnetic field, there are some direction conventions. When you find a dot in the question paper, not all the dots, when the question is related to magnetic field, the dot represents out of the page. Anything coming out of the page is either its magnetic field or electric field. Anything which comes out of the page is represented by dot, and anything which goes into the page is represented with a cross. Okay, so moving to the part which we were discussing. So let us consider that a magnetic field is moving into the page and a charged particle is thrown perpendicularly into the field in this direction, making an angle of 90 degree with the magnetic field. So in that case, it is observed that the path of the charged particle is circular. It moves in a circular path of radius r. Okay, so let us find out why does that happens. So as we all know, force is equal to QVB, and from the chapter rotational motion in our class 11th, we can derive that QVB is equal to mv square by capital R. That is the radius of the circular ring. Therefore, R is equal to mv by qb. Okay, so from here we can find out the angular velocity of the particle, omega, angular velocity, which is equal to v by r, that is equal to qb by m. Next is time period. Time period is equal to 2 pi by omega is equal to 2 pi m by qb. We are deriving these relations very easily, but do not try to go very deep into this topic because this is not very important. There is plenty of many of important topics in our syllabus. So this is not very important, but this topic is also not of that. This topic is also not that of very less important. So I discussed this. Then let's move on to the next part. Okay, one more thing. Frequency of revolutions. Frequency is equal to 1 by time period. So that is equal to qb by 2 pi m. That's all. Moving on to the next topic or next question. I'm attaching a note on this part which might be useful for you guys, but as I said, do not focus too much on this, but this is a little important, so I am writing it down. I'm attaching a note. Do check that, and I will also put that in my social media page. So these are some of the notes on motion of charge in magnetic field. Do check this out. Nothing very deep to explain, just go through it and go through the formulas. Questions might come. You might be given an angle at which the particle is entering into the magnetic field, and you may be asked to describe the path of the magnetic field, how it will be linear or circular, or how will the path be. So that's all about this topic. I will not take too much of time. Okay, one more thing I can add on. So what if the charged particle thrown at some angle to a uniform magnetic field? What will be the path? Okay, so the path will be helix then the radius will be mv sine theta divided by qb. Time period will be 2 pi m by qb, and finally the pitch will be v cos theta t is equal to 2 pi m by qb v cos theta. Okay, that's all about this topic. Then moving on further, cyclotron. I would suggest you guys to give less importance to this topic because cyclotron is not that very important for your boards, but just do look into it for once and check out its derivation, and definitely remember its frequency formula, which gives that frequency, cyclotron frequency, is equal to qb by 2 pi m. That's all. This is the most important formula. and rest you can go through cyclotron once, but that's not very important. I'll tell you which are the most important parts of this chapter. Moving ahead, another important thing of the cyclotron is kinetic energy of the charged particle in the cyclotron is equal to q square b square r square divided by 2m. Here q is the charge of the particle, b is the magnetic field, r is the radius of the cyclotron, and m is the mass of the particle. Radius of the cyclotron means the radius of the Ds. The cyclotron consists of two Ds, one in this side, another one in this side. Now moving to force. Force on a straight current carrying conductor in a uniform magnetic field.